Good day. Today we're going to be looking at graphing piecewise functions. Now, as a review, to solve for f of 0, f of 2, and f of 4, you have the answer key. For f of 0, you find at x value 0 which line it touches. It touches my blue one at 5. For 2, it touches at 3. For 4, it touches at 0. That is just a very quick review of how to do piecewise functions, evaluating them, that is, from the graph. Now, we're going to talk about graphing piecewise functions today. I'm actually going to skip this first one and let you do it later for practice. I'm going to do two of the ones on this page. I want to do the one on the top right and on the bottom left. In my opinion, those are the hardest two. I'm going to shadow those and let you do the rest as review, practice. All right, first, negative 2x minus 3, where x is less than 0. I'm going to graph this entire function by hand with a dashed line and then restrict it to this given domain. So negative 3 I know is my y-intercept, and my slope is negative 2. So I'm going to go down 2, right 1 to get the right side of my graph. And I'm going to do up to left 1 for the left side of my graph. And if you can hear that cricket in the background, I apologize. I don't know where it's at, or I would kill it. It has been annoying me all day at this point. Now, negative 2x minus 3 is the function when x is less than 0. So at my 0 coordinate, x value of 0 that is, I want to make that negative 3 value an open circle. It is less than, so I am wanting this left side. And I can erase now the bottom dashed part. For 2x minus 2, I know my y-intercept is at negative 2, and my slope is positive 2. So down to left 1 to go in the left direction, and up to right 1 to go in the positive right direction. And it says I want this between 0 and 1. Now both of these are less than and equal to, so I am wanting to get closed circles, and I'm connecting my dots. That is the entirety of my graph for net 2x minus 2. And I'm going to erase what is left over. Let me try that again. Small eraser. I'm just cleaning up that graph at this point. There we go. The next one says it is the value of 1 when 1 is less than x. So I'm going to go to 1 on my y-axis and do a dashed line. This time I made the lines far enough away from my other functions that I can erase them without having issues. It says 1 is less than x, so I'm going to be wanting an open circle at my x value of 1, and I'm wanting the right side of this graph. So I do not want anything on the left. There is my function. Now I can open Desmos and check my work. Once again, I do highly recommend changing your view at the end to match this graph. You can do it now if you want, which is what I'm going to do. just so it should look pretty much identical to what I have on my graph. So, negative 2x minus 3, curly bracket, x less than 0. That looks good so far. It matches the first function we did. 2x minus 2. Curly bracket, because I want this where 0 is less than or equal to x, less than or equal to 1. Also looks good. It matches what we have. And lastly, we have the function 1, where 1 is less than x. Now I'm going to hide that part where I typed it in, and our graphs match, so we did do it correctly. All right, bottom left. The absolute value of x minus 3, where x is less than 1. So, x minus 3 is shifted to the right 3 units. And it is the absolute value function, which looks like the v. And I want this where x is less than positive 1. So I want an open circle at my x value of 1. And I want the left side for that function. Now normally I do graph the entire thing with a dashed line and then erase what I don't need. But whenever I look at x minus 1 to the 4th, it tells me I want this where x is equal to 1. And this is one singular point, so I'm not graphing the entire function. I'm just going to plug in my 1 value. This is 1 minus 1 to the 4th. This is 0 to the 4th, 0. So at 1, that function gave me the value of 0. Finished. That was the entirety for that second function. All right, the square root of 4x, where x is greater than 1. Now, this one might be a little bit more difficult. If you want to see what the function looks like, you open up Desmos, SQRT, 4x, so there's my function, and I want this where x is greater than 1. Let's get out of that radical. So there's my function. Now, since I'm just trying to graph this portion, instead of going to the entire graph, I'm going to go to 0.5, because that's a little bit less than, wrong axis, 0.5 is a little bit less than the 1, and I'm going to go up to my 8, which is what the y-axis is. So there's my graph, what it's supposed to look like. At 1, it is supposed to be at 2. It's an open circle already. The next nice clean value we get is at 4, at a value of 4. Now we're going to keep going up. And I just want to see what it is at 8. At 8, we get 5.65, blah, blah, blah. So it's about right there. There's my graph. If you've not picked up on it already, you can just type these into Desmos to begin with, but I highly encourage you not to because I'd like for you to understand how these work together. All right, let's type in the rest of this. Absolute value of x minus 3 curly bracket x less than 1. If you don't know how to do absolute value on the computer, it is shift and then the button in between backspace and enter. So shift backslash is what it is. All right, and x minus 1 to the power of 4. To do a exponent that is not 2, you can do shift 6, which is the caret key. And I want this after I get off of that exponent. Where x equals 1. Okay, now I'm going to go ahead and change back my graph to the -8 to +8s. Our graph looks good, but there is something wrong with the picture. The something wrong with the picture is this dot at 0 or 1, 0. Why is this not letting, annotate, at 1, 0. The reason it does not show that up, Desmos cannot graph a singular point because it is a one-dimensional object and we can't even graph it realistically. Whenever we put a dot, we still have width and length, or height and width, however you want to say it. I mean, a dot cannot be graphed by Desmos, so you have to know how to find that dot for the x minus 1 to the 4th. Other than that, though, our graph does look correct, so we are good for this function. X that out real quick. All right, go ahead and pause this video, try the 3 that we did not do, and you will be done for the day. Here are your answers. That is all I have for you today. Have a great rest of your day.